Good morning. This is Miss Billerbeck, and we're going to talk about 16.3 sample space. So sample space S of a random experiment is the set of all its possible outcomes. So for a coin toss, the sample space, let's call it S. So S equals head or tail. So head is an element of the sample space S, and tail is an element of the sample space S. If a random experiment has a finite number of equally likely outcomes, then the probability that event E will occur is the number of outcomes for event E over the number of outcomes in the sample space. So we could write this simply as outcomes over possibilities. So the number of outcomes in event E would be written like this, and the number of outcomes in the sample space S would be written as this. So a multiple choice test has 5 options, A, B, C, and D. If a student guesses, what's the probability of getting it correct? B is the correct answer. So we're going to say F right here, F prime. Notice there is a prime here, so that means, that's right, the complement of F. So if we have the complement of F is the correct answer, B. So that means that F, if the sample space up here is A, B, C, D, and E, then F is A, C, D, and E. So let's count the number of outcomes in the original sample space. 1, 2, 3, 4, 5. And 1, 2, 3, 4 in the number of outcomes of, I'm sorry to say, failure, F. So the probability of failure would be N of F over N of S, the sample space. So N of F is 4 and N of S is 5. So that gives us a 0.8 or 80% likelihood that should we guess, we will not get the right answer. So we should probably study. So if S is our sample space, the probability of S occurring or being selected is 1. It always is. Because if everything in the sample space has an equal likelihood of being chosen. So for the probability of something in the sample space being chosen is 100% or 1. So if we have the probability of a complement of an event, we would write 1 minus the probability of that event from occurring. So E is the complement of the event E, the outcomes in this event. So this means therefore, the 3 dots, therefore, if the probability of E is 75% or 0.75, then the probability of the complement of E would be 1 minus 0.75 or 0.25. So let's look at, well, how does this happen? Let's look at that. All right. So the basic properties of probabilities. So if we have the probability of event E, it, of course, is the number of outcomes in event E over the number of outcomes in the sample space. Since E is a subset of S, so it's a part of S, maybe not all of S, it could be all of S, but it's got a lot of elements in S, but actually it could be 0 elements in S and still be a subset. So we have 0, it could equal 0, is less than or equal the number of outcomes in event E, which is less than or equal the number of outcomes in event of the sample space. Now, if we divide all of this by the sample space, something magical happens. Okay, so when we divide everything, we're not messing with the equation. Okay, it's proportional. So 0 divided by anything is just 0. Then we have is less than or equal the number of outcomes in E over the number of outcomes in the sample space is less than or equal to the number of outcomes in the sample space over the number of outcomes in the sample space. But you're probably wondering, what? So 0 divided by anything is 0. And this is just the probability of outcome E happening. So that's that. And then this, oh my goodness, this is the same thing as 1. So for any event E, the probability of event E happening is going to be from 0 to 1. And again, we have the 3 little dots here, which mean therefore. So we have created a wonderful little rule here that works for everything. So if we look at the percentages of the probability of event E happening, it would range from 0% to 100%. All right, let's do a few examples. Here. We have example 2. So we're reading a clock, reading in seconds on a digital clock, and it's observed at random. So S is the sample space. So let's look at what's in S. So if we start with 0 seconds, and 1, 2, 17, 18, 37, 38, 57, 58, 59, and we don't go to 60 because that resets at 0. So then we have at least one digit as 5 is the set for G. So what we're going to write is 5, 15, 25, 35, 45, and on here we can start with 50, 51, 52, 53, 50, 54, 55, 56, 57, 58, and 59. So let's count the number in the sample space. Well, we're not starting at 1, we're starting at 0 and going to 59. So that's actually 60. And we know there's 60 seconds in a minute. And then we need to count G. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there are 15 elements in the set G. So when we do probability and statistics, you should always try to write out your sets so that you can just count them, okay? It avoids a lot of mistakes. So the probability of G happening will be the number of outcomes in G over the number of outcomes in the sample space. So we have 15 outcomes in G and 60 in the sample space, which is 1/4, and that's 0.25 or 25%. Now, with what we've learned, to find the complement G, all we have to do is 1 minus 0.25, which is 75.75 or 75%. So if we add these two together, that equals 100%. So that's the great way to check. Now, if we didn't know this rule, we would just be subtracting 60 minus 15. Well, 60 minus 15 is 45. So we would write this, okay? And this equals 45 over 60, which equals 3/4, which equals 0.75, which equals 75. And that's exactly what we got right here, 75%. Okay, so this rule will save you a little time, but this rule is just perfectly fine to use as well. Okay, let's look at another example. All right, there are 15 cats, 18 dogs, and 3 rabbits in a pet store. An animal is randomly selected. What is the probability that the animal has 4 legs? All right, so first let's count up all of our sample space. So we have the number of samples. So we have 15 plus 18 is 33, plus 3 is 36. Okay, then we look at 4 legs. Okay, cats have 4 legs, dogs have 4 legs, and as far as I'm concerned, rabbits have 4 legs. So I am going to have to say that the number with 4 legs over the number of the sample space is the same, 36 over 36, which is 1, which is 100% probability. Okay, probability of an insect. Well, do we see any insects there? Nope. So the number of insects over the number in the sample size or sample space. So we have 0 insects over 36. So we have 0 or 0% likelihood that an insect is going to be selected. How about not a rabbit? Oh, well, that gets interesting. So if we know that the number for the rabbit is 3, there's 3 of them. So the number of the complement of the rabbit, whoops, I'm writing this wrong. Don't see my eraser, so excuse me. And so the number of the complement is going to be 36 minus 3. So the number of not rabbits is going to be 33. Okay, so if we write the number of the complement of rabbits over the number of the sample space, we can write 33 over 36. Okay, each of these are divisible by 3, so that's 11 over 12. Okay, if we use our dry erase calculator, the top dog goes into the house. So we have 11 and 12. All right, so there are 0, 12s, and 11. In 110, we have 9, which gives us 108. Subtract, and we get 2. And we have 1 in 20. And then we get 80 down here. I ran out of room, but when we do that, we get 80. So that would be 6. So what we can say is that this is going to round to 0.92 because the 1 has a 6 next to it. So 5 or more raise the score, 4 or less let it rest. So the 1 gets raised to a 2. So that means that it is a 92% probability of choosing an animal that is not a rabbit. So there you go. And I hope this helps you a great deal to do your homework. Have a wonderful day.